Yes, looks good.
Okay. Should we start?
Yes, sir. Let's go ahead and get started and
Okay.
run with it. Thank you.
Well, no problem. So good afternoon, everyone. Thanks for joining us for the ECN Department Tech Talk. So my topic is when AI and vision and robotics work together, what will happen? And a very brief introduction of myself. So my name is DJ Lee. I'm a professor in the ECE department. So I received my MS PhD degrees in electrical engineering and an MBA degree from Shenandoah University. So I consider myself a teacher, researcher, inventor, and entrepreneur. Served in the machine vision industry for 11 years, and then finally decided I want to do something more meaningful. So I went to BYU in 2001. I started robotic vision lab in the department. I also co-founded a company called Smart Vision Work. And today's talk will have some of the work that we have done over there. And also co-founded a company called Authentication, and I will introduce our technology in this presentation. So Robotic Vision Lab, so I established it in 2004 with the focus on processing visual information for robotic applications. So we're not just interested in developing an algorithm or develop a software. We want to actually use it to solve real world problems. So my current research focuses on artificial intelligence, specifically for vision and robotic vision, visual inspection automation, and high performance visual computing. So we have been focusing on these four areas in the last about 15 years. Since 2001, we have 9 PhD, 15 MS students graduated, and mentor 42 undergraduate students in the robotic vision lab. Okay, so what can a robot do with brain and eye? So normally when we talk about robots, we just think about mechanicals or robot arms or cars, but we never really give much credit to the brain and the eye that make it all possible. So here is one application that I want to show. So this is people sorting potatoes. And this is AI vision sort potatoes. So it's a robot arm controlled by a computer that has AI and the visual computing capability and work together to pull out defective products. In this case, like a green spot or rotten spot on the potato and the odd shape of the potatoes. So this is all done by AI vision to control a robot arm, and it can perform about 60 picks per minute. So it's quite fast. You know, it's not if it's about as fast as a human can do. And this has been installed in a lot of potato facilities. AI vision can also sort beef. So beef product comes out of the production line, and we sort them and put them the right part of the beef into the right box. And this is also possible with the AI and the vision. So we need some capability to process visually. So without the brain and the eye, this robot cannot do very much. But with that vision and brain, it can sort and pick the products that we're interested in. So AI vision may also be better than human vision. So just a quick test. You can see two pictures on the screen. On the right, on the left, there's something in there that shouldn't be there. This is beef. The background is beef. So on the left, there's some material that shouldn't be there. And I don't know if you can tell, but I'll just show you the answer. So the one on the left has paper towel. The one on the right, see if you can find it. If you can, that's okay. You just have normal human vision. But with AI vision, this is something that's possible. So this is a cotton glove in beef on the conveyor belt with the beef. On the left, there's also something shouldn't be there. AI vision caught that cotton glove. On the right, beef with rubber glove. Next one, we can see this one is hard for a human, okay? So this is a meat tag mixed with beef. On the right, it's easier for human vision because the background is blue, so it's quite obvious. So the strapping plastic. On the left, packing strap. And the last one on the right, it's a piece of pallet wood. Okay, so with training, AI vision can do all of this. Okay, sometimes human vision just for whatever reason, just not doing as good a job as the AI vision can do. So this is kind of a summary of the result of the AI vision, a robot with brain and eye. So over 2 months at multiple facilities, 300 million images processed. And these are the objects that the AI vision found. Bone and cartilage, 193 gloves, 55 pieces of plastic, meat hook. This is metal hook that hook on meat. And if this is not detected, it's going to damage the grinder. Okay. So this is for production to produce hamburger meat. So we need to pull out the material, the foreign material that are not supposed to be mixed with the beef. Found 32 knives, candy wrapper, rope, even bandages. So workers lost the bandage on on their hand or fingers. Okay, cardboard. So these are the materials that it's not supposed to be mixed with the beef. So I like to say that without AI vision, our hamburgers may just be a little bit too tasty than we want with all this weird stuff mixed in the beef. Okay, AI vision also have been successfully used for sorting shrimp. So on the left is a shrimp processing machine, and that's the result. So the goal is to sort shrimp, like broken shrimp or shrimp with shell or some defects. And I'm showing you a quick video of what it can do. So the shrimp transfer on the blue conveyor belt, and while they're in the air, AI vision detects defects and then eject them off the trajectory and blow them down onto this output here. And the good ones get passed through. Okay. So this can be used for sorting the size and detecting defects, removing defects, and it can run at very high speed. So the next one, AI vision, it's used to sort fruit. I'll just show you a little, the first part of it. So these are dates. They're being washed. So they have the brushes to wash them, elevate up to a conveyor system. Oh, sorry. Skip that. And then transport them onto a shaker, shake them into single files and single layer, and then go through the light chamber with the camera. And this is what the computer sees. And it's sort of 68 dates per second. That's much faster than a human worker can do. And the last part is the interesting part. So if you notice, as they travel down the chain, they get blown off the chain to the spot that they're supposed to be. So the result is that you have the same grade to the same conveyor belt. And this is done to sort date more accurately and reduce the labor cost. The next project is a student project. So we name it Hummingbird Project. So it's a drone. I'll just show you a part of the video. So this is a drone hovering in the air, and it will detect the flying object and try to intercept and catch it. So it take off by itself. And then it look at it in the sky and flying object and try to catch it. Okay, there are real applications for this. This looks fun, but there are real applications. Like maybe you can use a drone to identify birds that are going to eat your crops. So you can use drone to chase them away, but you want to recognize what species they are, so you don't accidentally kill endangered species, and you only just have a smart way to protect your crop. So it's a very interesting project. And someone told me this could also be used for like a wind turbine to chase birds away so they don't kill themselves. So it's a very interesting project. This is a class project of use vision to catch a baseball flying about 55, 60 miles an hour. So this is a baseball pitching machine. The ball comes out here. It's inside has a flying wheel, and the ball will fly 55, 60 miles an hour. And on the other end, we have a robot with a net and then two cameras on the top as the stereo vision, like you see over here. These are two cameras looking at the ball, estimate the trajectory of the ball, and try to intercept the ball, okay, to catch it. So I'll show you a video here how it works. So this is a slow motion, and you can see the orange baseball fly, and then it hit the rim, so that doesn't count. So now it's a catch. So this is all done at that high speed, and the computer has roughly 0.3 second to make a decision and move the net to catch the ball. So everything must work in real time. To locate the ball, estimate trajectory, decide how to move the net, and try to catch it. The one on the right is a newer version. You can see the ball comes out of the pitching machine at 55 miles an hour.
All right, go. You want to?
So this is an improved catcher that it works faster and better control.
Catch.
So yeah.
Catch.
So when a robot with vision, that's what it can do. It can catch a baseball. Okay, so some of you might have seen this in a video in the hallway or somewhere on campus. So this is a foosball robot.
Ladies and gentlemen, to this matchup of humans versus robots. You heard me correctly. Flesh and blood versus ones and zeros. It's sure to be a flame ball of a football matchup today.
So we're building a robotic vision controlled foosball table. So the objective is to defeat a human player.
Stutter step, and it's a perfect execution of magnificence. This is what boys dream about, ladies and gentlemen. Watch the keeper now. Flames it across an entire flock of defenders.
So the blue are controlled by the computer with AI vision. So we have motors on each of the blue rod, and the yellow players are played by human. And we had a game human against the computer.
Into the belly of the dragon.
So students all try to mimic how human play the game, and they program their ideas into their code. It actually reacts a lot faster than human.
We're seeing that it's becoming a challenge for the
Oh, it's good. Sorry.
Ideas into their code.
AI.
The defense's algorithm reads it perfectly. It's a wonderful. Look at the disappointment in his face.
So the robot score
We
again.
need a computerized foosball table, but it is a small example of a much larger problem.
Through this project, students
So this was a project for students to work on a few years ago, and robot with vision, and we're able to play foosball. The next project that we have done in the lab is an app to help basketball players to do better free throw.
44.
So the idea was to estimate the incoming angle of the basketball and then give that angle to the feedback to the player in real time. So the goal is to, when you're practicing free throw, then you want to control your muscle to shoot it at the specific angle. So I think 45 degrees will be, you have the maximum chance to make the shot. So the real-time feedback can help user train the muscle. So you gain your muscle memory. So when you stand there, you will know which muscle to use to get it to that ideal 45 degree to make the shot. So this is a very good project and has real application. Okay, the next one is we just finished recently, like on Wednesday. So this is the picture of the city of Leehi. Okay, so it's two E's, not one E, because my last name is Lee. So it's a city of Leehi. So we built paper buildings. We have railroad crossing. We have a few traffic lights and stop signs and all the road signs, different kind, school zone, deer. So when the car drives on this road, it will have to detect traffic light and make sure it's green before it can proceed, or see the stop sign, stop before you go. And the railroad crossing, you want to see if it's flashing red light. If it's flashing red light, you shouldn't cross. And there's some other signs that the car will detect the sign and then play a pre-selected music to indicate that the sign it's been detected. And that's a close-up view of the city of Leehi. There, it's a BYU. It's located in the city of Leehi. So, we have a Costco building. We have school, church, apartment buildings, shopping center, the residential area. So it looks pretty real. Okay. So this is a short one, and I'm going to just skip forward, show you a small clip. This one. So it's I don't know what 2x or 8x speed. You see stop at the stop sign and the traffic light. You don't go until it's green. Stop at the railroad crossing. And you go when it's safe to go. It's a very interesting project for students to learn fundamental knowledge about self-driving car. So we have deep learning to detect traffic signs, detect traffic light. We also have AI and train it to drive in this city and obey the traffic rules. So it's a graduate course project. Students learn, and hopefully one day they can get a job for any autonomous vehicle company. So that's AI and vision and robot. So that's the car. It's the robot in this case. This is a quick video showing kind of the old video showing how the cars drive in the city. You can see the multiple cars going at the same time. Next one. So this is a bird's eye view of that City of Leehi. This is an older version, but we have 5 cars driving at the same time, and they stop. This intersection has a traffic light that control the flow. It's pretty cool using AI vision. So all this that we have done in the past, and we focus on using AI and vision and add them to a robot or a car, or to perform all different kind of tasks. Whether it's to cut cost for production or it's for real use to improve sports performance. Just want to show that AI vision can do pretty much all of this. And the next, I have a few like new projects that we are interested in doing. In talking to a company about the tennis ball. So here it's a video that show you that we record a video and we can detect the skeleton, the joints of this player, and then we can analyze their mechanics, and we can also determine it's a serve or it's a forehand or backhand. So we can help analyze the whole tennis match automatically and then gather the information for the coach to use to help the players to improve their game. So this one, it's ongoing and should be a very interesting project for using AI for body motion analysis. The next one, it's something similar, AI body motion analysis. This one, we aim at analyzing golf swing. So our goal is to be able, like the basketball project, we're hoping the real-time feedback to the golf player can help them train their muscle memory and improve their performance. So it's a video. So I recruit a BYU golf team member, and she record good videos of good swing for us. And then we use that to train our AI algorithm. And our goal is to be able to give you a score, compare your swing to a good swing or ideal swing, and then give you a score, and you can get that real-time feedback to improve your game. And this one is currently put on hold. There are people interested in exploring this idea, so we will then continue it in the near future. Okay, some of you might have seen this news on BYU front page. So we used AI to recognize football formation. So this is video collected from, I don't know, some of you might have this game. This is collected from Madden 2020, I think. So we pick a formation and then we play the game. Yeah, what cool research like this can be, right? Play video game. But we collect the video image for AI to train the AI and analyze the formation. So we first locate the players, and then we determine using AI to determine what position each of them play in. And then with that information, we then classify what kind of formation. So this is good for automatic annotation of game video. So that will help eliminate manual process of collecting football game information, and can be used for coach to do better game planning to train their players or for prepare for their future games. And we use deep learning for this project. The result was very promising, and we are talking to some potential collaborators to move forward with this project, and we're hoping we can help BYU football team in the near future. So the next one, some of you might have seen this. This is called Face Connect. It's a function that's available for Genesis GV60. It's an electric car. Show you this is a short video.
Cheerful, charged, happy, enthusiastic. No matter how you feel today, Face Connect.
Okay, this is a commercial from Genesis. Okay, and the reason I show you this video, it's because they have this function called Face Connect, and it's facial recognition to get in your car. So we are proposing something more secure than just simple facial recognition. Then our approach is to address these challenges. Okay, so for facial recognition, for authentication, we're facing a lot of challenges. Okay, so for the current authentication methods, what if your password is compromised? Stolen or misplaced key card, two-factor verification. I really don't like the two-factor verification because sometimes I will run to my classroom and try to log into the computer to teach my class, and then I forget my cell phone. So I have to run back to my office to get my cell phone. So that I can perform this two-factor verification in order to get access to my PowerPoint presentation. So it's not very user-friendly, in my opinion. High cost sensors to scan the your iris scanning or perform fingerprint recognition. So very expensive or inconvenient. Also, there are companies making fingerprints for you or fake face image to hack into the system. Also, if you use biometrics like fingerprint, you can't change fingerprint. If someone have a fake print of your fingerprint, and you can't change it. Also, lack of liveness detection. What if you are not aware, or you're sleeping, or you're not unconscious? How would the system know you are aware? Okay, so these are the challenges that our technology can address. I did a very quick YouTube search, fake fingerprints or fake facial recognition, and I got like hundreds, if not thousands of results from the search. The people teaching you how to make fake fingerprint, how to teach you how to fool the facial recognition system like this one. So this is a photo of you, and you can fake that facial recognition and then access the system or your phone. Okay, so it's not very secure, although they're both biometrics, so that you don't have to carry another device with you, but they're not very secure. So our approach is a two-factor, but only one camera that you can do two things at once. One is the facial appearance, so like the conventional facial recognition. The other one is facial motion. Okay, so you need to pass both tests. That is you. Also, you make the right facial motion password. And this password is set by you, and you can change it anytime you want. Kind of like changing your password, but it's biometrics and you can reset it. So that's the advantage of this technology. So it's much more secure than the conventional facial recognition. And we call this wink. So you could get in front of the camera and just wink, and you can get into the system, you perform all different kind of tasks. A short video just to show you. It's one of my students. So we have a camera mounted on our door of the research lab, and he raises his eyebrows, and then he can get access into the lab. The one on the right, Chat, is the other student in my lab. So he made a special mouse movement, and then he got money from a lunchbox. So these are the potential applications. Access management, hospitality, like you get into your hotel room, you can just wink and you can get in your room without even your phone. Residential area for security, like if you have this function on your Ring camera, and that will make it more secure, you can get in your house. Human computer interface, also for that Genesis, keyless entry, or even once you get in a car, you perform driver verification to confirm that's you. Banking, ATM, safe deposit box, online transaction, all this data security, anything that you need to authenticate your identity, you can use this technology to increase the security level. So wink, I think it's the future of facial recognition. We also use AI vision to help reduce pollution. So we have camera and computer to monitor the burning of the flare at the oil well. So when they drill for oil, the gas leak, and that gas must be burned. They cannot escape into the atmosphere. That's bad for the air. Okay, so we use AI vision to monitor if there's a smoke, if it's burned right, or need to be improved control. The last slide I have is a future project. We're writing a proposal. So we want to use AI vision for orbital applications. This one is for orbital slim or the visual odometry. So put a system on the satellite. So use vision to detect debris or find the location of the satellite without using any haptic sensors like LiDAR or radar because they cause interference. So vision is the best sensor without causing any interference in orbit. So that's our future project. That's all for today. Any questions for me?
Dr. Lee, you have a question in the chat. It says, what are some of the topics that I could study on my own to get started with computer vision?
Oh,
PyTorch, OpenCV, some topics that will help.
yeah. I think vision, we use OpenCV. Well, the first thing is make sure you are a good programmer. So you want to be able to program well. And you want to learn OpenCV. And we do, in the lab, we use PyTorch, but TensorFlow also could be another popular choice. So these two, and then you want to learn about like deep learning. That's what we use to perform the AI vision. So these are the things that you need to know, and then you can get into this field. Okay,
Thank
other
you.
questions?
I don't see any additional questions. If you do have additional questions, pop them up in the Q&A.
Uh-huh.
And if not, we will end there. And thank you, Dr. Lee.
Oh, no problem. Just email me if you have any questions, if you're interested in this field. Okay,
Thank you very much.
you are welcome. Yeah, thank you for joining me here.
Thank you, everyone.